So 6.1b lesson. We are building triangles given 3 measurements in this lesson. So it's really important you understand these couple of definitions. Included angle of a triangle. So an included, this is a keyword, included. Okay, the definition, the angle formed by 2 adjacent means they're next to or neighboring sides of a triangle. Okay, so let's give a little picture of that. So I am just drawing any old triangle. Okay, so there's my triangle. Okay, I'm going to draw your attention to this side and this side. And then this angle right here, angle A. This is an included angle between side AB that's labeled and side AC that's labeled. Okay. If you're looking at angle B, for example, that is not included between side AB and side AC. Okay. All right, let's look at this guy right here. Included again, but this time we're talking side. Okay, up here we were talking angle. Okay, let me scooch this in a little bit. Okay, so again, I'm going to draw just a random triangle. Okay, and I'm going to direct your attention to this angle and this angle. Okay, this is different. I'm putting 1 mark through one of them and 2 marks through another one. That means, hey, look at us, we're angles, but we're different. Okay, and then this side right here, is the one that I'm drawing your attention to. So side BC, this side is included between angle B and angle C. Okay, so the side formed by 2 angles that share a common segment or ray in a triangle. Okay, so this side BC shares between this side is shared between this angle B and this angle C. Okay, so it's really important you understand the words included, and then with that comes non-included that we're about to talk about here in a couple of examples. All right, number 1, circle all the triangles with side lengths 8 and 5 and an included angle of 32 degrees. Okay, well here's side lengths 8 and 5. This angle would be included. That is not included. Okay, so A does not work. Here's 8 and 5. Between those 2 sides would be this angle right here. So B works. Okay, here's 8 and 5. Included would be that angle. 32 is not included. So the only one you're circling is B for this situation. All right. Number 2. Circle all the triangles with side lengths 4 and 3 with a non-included angle of 50 degrees adjacent to the side with length 3. That's a lot going on. Okay, let's take this a piece at a time. So I've got my 3 and 4 side lengths. Included would be here, so we're good. 50's non-included. Okay, now is the 50 adjacent next to the side length 3? Yes, it is. Okay, so this is non-included and adjacent. So A works. All right, let's look at this guy. We've got 3, we've got 4. Included would be here. So 50 is non-included. Is it next to the 3? Yes, it is. It's adjacent to the 3. So B should be another one that you're circling. Let's look at this guy. We've got our side lengths 3 and 4. This would be an included angle. So this is non-included, but is it next to the 3? No, it's next to the 4. We are not circling that one. Okay, this guy, we've got our side lengths 3 and 4. Ooh, 50's included. That automatically makes it not work. Okay. All right, one more of these. Number 3, circle all the triangles with two angles 90 degrees and 28 degrees with an included side of 6 units. All right, so we've got our 28 degrees and 90 degrees. Is 6 included between? Yes, it is. Okay, letter B, we've got our 90 degree and our 28 degree. Included between would be here. So nope, this one does not work. We've got our 28 degrees and 90 degrees. Included between 6 would have to be here, so that one works. Okay, so from those few examples, you should be understanding what included and non-included are. Okay. All right, the next page of notes is kind of like a fill-in chart. And I really would like you guys to print out my answer copy key to this or jot this down as we're about to go through it. Okay, if we were present in class right now, there would be 5 stations that you would be going to, and we would be constructing some triangles depending on what's told to us to construct. And then we're going to compare them with everybody at our table and say, with these directions, am I able to create one or more than one unique triangle? Unique just means special. So do we all have the same special triangle with those requirements that were given? Or do all of us have different ones with the requirements that are given? Okay, so I'm going to kind of be bebopping back and forth here between some pages. Okay, station 1. Station 1 says a triangle with 3 specific side lengths. So station 1, we are asked to draw an equilateral triangle each side 4 inches. So we have a triangle with 3 specific side lengths from that other piece of paper. All right, so here's what I drew. If you drew it and somebody else drew it, guess what? There is no other way this triangle would look. Okay, I had to play around. I drew my 4 inches and then I had to play around up here. I had to play around up here where that dot, that vertex would be to make that side 4 inches and that side 4 inches. We would all have the same triangle. So you're going to conclude one unique triangle. Okay, so 1 and then 3 specific side lengths can only result in one triangle. Okay, station 2. Station 2, we're asked to look at 2 specific side lengths with a specified measure for the included angle. Station 2. Excuse me. All right, so station 2, we are asked to draw a triangle that has 2 sides that are 4 inches with an included angle measuring 80 degrees. Okay, so I took the words right off our printed copy. It says we're looking for a triangle with 2 specific side lengths with a specified measure for the included angle. Okay, well, let me show you how I did that one. I started with a side length of 4 inches, and it told me that we needed an 80-degree angle between 2 sides of 4 inches. Okay, so I started with this side, measured my 80-degree angle, drew a long line, and then I measured that long line to be 4 inches, and then I connected those two vertices. If you did the same thing, and if someone else in our group did the same thing, there is no way any one of us would draw anything different than this. Okay, it's really important to understand this is not different. It's just rotated. This is not different. Okay, also, if you could see through this paper, so I flipped it over, you can kind of see through. Okay, that's not different. It's just flipped over, reflected. Okay, so that doesn't make it different. That just means that it's just the paper's turned some other way. Okay, so our conclusion on this station 2 is one unique triangle. Okay, so either you printed this page out or you're writing this in. One, you're doing one triangle. 2 specified side lengths and a given included angle can only result in one triangle. Okay, that's the upshot of station 2. All right, station 3. This time we're given 2 specific side lengths with a specific measure for the non-included angle. How many included angles versus non-included angles does any triangle have? Hope everybody's thinking you're going to have one that's included and that leaves 2 others that are non-included. Okay, so here's station 3. We were told to draw a triangle with sides measuring 4 inches and 3.25 inches with a non-included angle measuring 50 degrees. All right, so let me show you how that looks. I've got my 4 inches. I've got my 3.25 inches. And I have to have the 50 either here or here. Okay, this is included. Okay, well, if I have 2 places I could put a 50-degree angle, don't you think I'm going to get 2 different triangles? So here's one look. There's one look. And look at the other look. Here's my 4 inches. Here's my 3.25 inches. And this time I put it off the 4 inches. This last time I put it off the 3.25 inches. So they're very different looking triangles. More than one unique triangle. So if we were sitting in a group, some of us would have this looking triangle and some of us would have this looking triangle. Okay, so your answer for station 3, get the right paper over there, is more than one. Since the given angle can be attached to the end of either given side length, as long as it's not between those 2 given sides, then there are 2 different triangles can be formed. Okay. Station 4. A triangle with 3 specific angles. All right. So our instructions in this station would be draw a triangle with angle measures 30 degrees, 100 degrees, 50 degrees. Okay, so off that sheet, we're looking for a triangle with 3 specific angle measures. All right, well, here's one look of that triangle. Let's just say that's what mine looked like in a group if we were sitting together. Somebody else, ooh, look at how different that looks. It looks like a shrunk down version of that, doesn't it? Okay, and then this one is a slightly blown up version. So couldn't we be here forever doing them as little or as big as we want while maintaining the 100 degrees, 30 degrees, and 50 degrees? Okay, so the answer to this one is more than one unique triangle. Okay, so our answer on this sheet, if you didn't print it out, you're going to write more than one. Given only angle measures, many different triangles can be created. In fact, an infinite number. More than one, but an unlimited number, depending how big or how small you have those side measurements. Okay, got one more station. Station 5. Two specified angles with a specified measure for the included side. Well, here were our directions. Station 5, draw a triangle with a side that measures 4 inches and two angles coming off that side, 30 degrees and 50 degrees. Okay, so this is two specified angles with a specified measure for an included side. Okay, so I've got my 4-inch side. Sorry for that little bump. I had a bump in my plastic ruler. Got my 4-inch side, and off these edges, I've got a 50-degree angle and a 30-degree angle. Okay, now these could be reversed. If they were reversed, you'd just be looking at it upside down. You can kind of see it through the paper. Okay, so when you do those and extend the lines, they're going to cross somewhere. If you did it also, you would be creating the same exact triangle that I just created. Okay, so one unique triangle. All right, so let's get that little sheet back over here with all of the answers on there. Station 5, you're going to write 1. Two specified angle measures and a given included side length can only result in one triangle. Okay, this sheet needs to be memorized. This sheet needs to be memorized. If you don't understand, if you think through what they're asking for, if you don't understand, then you have to memorize this. Okay. All right, now we're going to apply that on some of these questions on the last page here. All right, so decide whether there are none, one, or more than one possible triangles with the given conditions. Use either a ruler and a protractor or graph paper strips and protractor to draw the triangles. Okay, a triangle with sides that measure 3, 4, and 5 centimeters, does this form one unique triangle? If possible, what kind of triangle is formed? If not possible, state why not. Labeled picture. All right, let me get my pens and my protractor and ruler. Where's my protractor? Oh, here it is. All right, so I've got, I always draw my longest side first, 5 centimeters. Okay, if I'm starting at 0, 1, 2, 3, 4, 5 centimeters. Label. Okay, now I need a 3 centimeter and 4 centimeter. So I'm going to change to a pencil because I'm literally going to be trying and erasing, trying and erasing, trying and erasing. So here is 3 centimeters. Here's 3. I'm not going to write it because I'll probably have to erase it. Let me see if that dot gets me 4 centimeters. No, it does not. It only gets me about 3.4. Okay, so I've got to go, I'm kind of running into this base here. So I'm going to have to probably move my paper away here in a minute. So I need to go kind of way up a little bit more. So here's my 3. This is 3. Now let's see if that gets us 4. Look at that. It gets us exactly 4. So now I can go ahead and trace 4 centimeters. And then I got my 3 centimeters. Yep, exactly. All right, so there's my labeled picture. Does this form one unique triangle? Yes. What kind of triangle is formed? Well, these are all different side lengths, and this is a 90-degree angle. If you measure it, it would show 90 degrees. So this is a right scalene triangle. All right, a triangle with angles 100 degrees and 20 degrees and an included side of 2 centimeters. So I need to do my 2 centimeter side length. That's teeny tiny. 2 centimeters. All right, I need 100 degrees coming off of one of these dots, these vertices. 100 degrees would be right here. I don't know how long, so I'm just going to draw a long line. What I do know is this is 100 degrees. And then I need 20 degrees off of this one. So 20 degrees is only right here. So I'm going to draw a long line through there wherever it crosses. So this is 20 degrees. Okay, so I've got two angles with an included side. Does it form one unique triangle? Yes, there's no other way anybody else's triangle would look different than this. So yes. All right, I can see that I have different side lengths. If you need to measure them, then do it, but I can see they're different. And then I also know that this is bigger than 90 degrees, so it's an obtuse. So I've got an obtuse scalene triangle. All right, number 6. A triangle with two sides of 5 and 7 centimeters and an included angle. So I'm going to draw my 7 centimeters first. I always draw my larger one first, just because I know I have the space for it. So 7 centimeters is here. Okay, I need one of these angles to be 45 degrees. Oh, sorry, guys, I need to scooch it up. I need one of these angles to be 45 degrees. It doesn't matter which one. Let's let this one be 45 degrees. 45 degrees is right here. It's halfway in between 40 and 50. Okay, I'm going to just draw a long line through there. I don't know how long it needs to be, so I'm just making it long. I know that this is 45 degrees. Okay, now, this angle needs to be included between a 7 centimeter and a 5 centimeter. So this needs to be 5 centimeters. Five centimeters is going to be right here. 5 centimeters. Now, do you think if you made this triangle also, it would be the exact same thing? Yes, it would be. All right, if I measured these, this would come out to be 90 degrees, and these look the same. 5 centimeters. Let me see if this is 5 centimeters. Yes, it is. Pretty much as me as a human can do. Okay, so this was 5 centimeters also. So this is going to be right isosceles. So yes, this forms a unique triangle. Right isosceles triangle. All right, let's look at this number 7. A triangle HIJ in which HIJ is 60 degrees, JHI is 90 degrees, IJH is 55 degrees. Okay, let's pause for a minute. Whenever we're given 3 angle measurements, let's pause and make sure that they add to 180. No, we're at like 205. So no, this doesn't form a triangle. The 3 angles, it says to state why not. The 3 given angles add to more than 180 degrees inside any triangle. Let me scooch that up because my little picture's blocking it. Okay, let's do that last number 8. Okay, you are going to see questions on your quiz like this. Okay. Determine if the given conditions would produce a unique triangle, only one triangle, or if more than one triangle can be made with the given conditions. Circle one unique triangle or more than one unique triangle. More than one triangle. All right, so if you are given 3 angle measurements, okay, let's go back to this sheet right here. 3 specific angles is more than 1. Okay, we need to make sure that this adds, though, first of all, to 180, and it does. I just did a quick check in my head. So more than 1. A triangle with sides 15 meters, 20 meters, and an included angle of 52 degrees. Okay, so 2 given sides and an included angle. 2 given sides and an included angle right here. 1. A triangle with side lengths 3 centimeters, 4 centimeters, and a non-included angle of 83 degrees. Okay, well, we've got 2 given sides and a non-included. 2 given sides and a non. 2 given sides and a non-included angle is more than 1. So you can see why you need that page memorized. Last one. A triangle with side lengths 10 inches, 13 inches, and 4 inches. So on this little cheat sheet here, a triangle with 3 specific side lengths. A triangle with 3 specific side lengths is 1. Okay, here's something that you need to understand. Anytime you're told a situation with the word included, that is a very specific recipe on how to build a triangle. You're all going to build the same one. It's one unique triangle. Anytime you're told non-included, okay, that gives you some choices. That gives you some options. So we're going to have different looking triangles within our group. So that's more than 1. Okay, and then you've got this one with angles, all angles. Okay, can't you make the sides very small or very big with the same angles? Okay, and then we've got the other one is the, what is it right here? The 3 side lengths. Okay, there's no way, you'd have to play around with the sides or with the angles where to put them. Okay, but there's no way anybody's triangle would look different. That's a very specified looking triangle. Okay, all right, so this sheet right here is key. It must be committed to memory, either by an understanding of it, the way I just spoke through them, or by memorizing them. These will show up on your quiz and test. You need to understand these. This is a very large concept for our standards for 7th grade. Okay, thanks, guys.